Welcome back, guys. On this video, we're just going to take a look at the events that are called mutual exclusive event and the mutual exhaustive and the complementary events. Those three events are different, and on this video I'm just going to show you the difference between those kinds of stuff and how are you going to prove it in your exam. So without wasting more of your data, let me just get straight to the point. So that is what we call, the first one is the mutual exclusive event. So the mutual exclusive event, an event actually is called mutual exclusive when two events don't intersect each other. When they don't share a common outcome, we call it kind of event a mutual exclusive event. What do I mean? When event A, let's say, when the probability of A and the probability of B is equal to what? To 0. So an event is called a mutual exclusive event when they don't share a common outcome. We can be able to see it in this kind of Venn diagram. These two events, let's say this one was event A and event B. Event A and event B don't share anything in common. So this kind of event is called what? These two events are called mutual exclusive event. Why? It's because they don't share any common outcome. So we can conclusively say that for if two events are mutually exclusive, the probability of A and B, it has to be equal to what? It has to equal to 0. So this kind of stuff, it has an effect in our formula. So if the probability of A and B is equal to 0, it means on our formula, where this formula, I hope we've made a video, but we talk about this formula of A or B, where it is equal to what? The probability of A plus the probability of B, minus the probability of A and B. So when when two events are mutually exclusive, it means that the probability of A and B, it is equal to 0. So that kind of stuff, it has an effect on our formula. It means here is going to be equal to 0. So therefore, if the two events are mutually exclusive to each other, it means that the probability of A or B, it has to be equal to what? The probability of A plus the probability of B. So whenever they say on a statement that the probability that two events are mutually exclusive, what you have to conclude? You have to conclude that the probability of A or B and B, it has to be equal to 0, and the probability of A or B, it has to be equal to the probability of A plus the probability of B. So that's what it means when they say mutual exclusive events. So secondly, there is what we call the mutual exhaustive event. So when we talk about mutual exhaustive event, this one is very, very confusing to a lot of students, but it's very easy. When we talk about mutual exhaustive events, it's when two events, it's when all the possibilities that are inside the Venn diagram are all used. What do I mean? It's when the probability of A or B, it is equal to what? It is equal to 1, Okay, guys, what do I mean when I say for an event to be mutually exhaustive, the probability of A or B, it must be equal to 1? What I mean is that all the total sample space, they must be grouped together. They must contain that kind of cycle A and cycle B. It must contain all the elements of the sample space. There must be nothing that must be found outside those kinds of cycles. So when we count what is in cycle A and what is in cycle B, it must give us 1. In other words, the best way to differentiate between a mutual exclusive and a mutual exhaustive. In mutual exclusive, you are allowed to, if you notice on the first diagram, there is 0,1 outside those kinds of Venn diagram, but on the Venn diagram number 2, you are not allowed to put something outside those, to put any sample space outside those kinds of circles. Everything must be filled inside those kinds of 2 circles. So that's what they mean when they say an event is mutually exhaustive. So to prove that an event is a mutual exhaustive, you just have to show that the probability of A or B, it is equal to 1. Or you can draw a Venn diagram whereby you show all the elements that are used all in a sample space. That's how you can be able to prove So going to the third one, which is simple, which is, we call them a complementary event. A complementary event, actually, this one, an event, two events actually, A and B. For example, this one, let's say this one is A and B, and then even this one I didn't mention it, A and B. Two events, A and B for this one are said to be complementary event if they are both exhaustive and mutual exclusive. What do I mean by this? Two events are complementary when they are what? They are first mutually exclusive. Secondly, they have to be what? They have to be mutually exhaustive to be able to be what? To be complementary event. An event is called complementary event when it is both mutually exclusive and mutually exhaustive. So what can we conclude by that kind of stuff? We know, so in order for that kind of event to be complementary, it means that the circles don't have to intersect, because when it is exhaustive, the circle don't intersect. It means it does not have to intersect, and also it has to be exhaustive. When it is exhaustive, it means that there must be nothing outside those kinds of circle. All these kinds of event, all the outcomes must be inside the circle. So can conclusively say that the event is complementary event when the probability of A and B is equal to what? To 0. This one represent what? The exhaustive, and then also that kind of event, it has to be the probability of A or B, it has to be equal to what? To 1. So that's what we call a complementary event. It has to be both exhaustive and exclusive in the same time, and also by this kind of stuff that we are saying here, it is going to also have an effect also in our formula. Even this one, it is going to, but this one it is going to have an effect in our formula. So if the probability of A and B is equal to Z, the probability of this one has to be equal to 1. It means that also the probability of A plus the probability of B, it has to be equal to what? It has to be equal to 1 for an event to be what? To be a complementary event. So that's what I want you to take away from this kind of video, that the mutual exclusive event, it means that those kinds of two common events, they don't share anything in common. And the mutual exhaustive, it's simple. The probability of A or B, it has to be equal to 1. This one, guys, is the same even if it is at something like this. Even if they don't intersect, as long there is nothing outside here, let's say there is 2 and 4 here, and then as long there's nothing outside, that kind of event is what? Is exhaustive event. So then the complementary is simple. It's when the event is both exhaustive and exclusive, So the kind of event is complementary event. So to make you understand this kind of, they're not going to complicate this kind of stuff in your exam. They're going to just ask you some few questions whereby they will need you to prove this kind of stuff. So let me just show you some few questions whereby they're going to ask you this kind of stuff. So now let's just take a look at this one. It says that if A and B are mutual exclusive events such that probability of A is equal to 6, the probability of blah, blah, all this kind of information. They say determine the probability of A and B and the probability of A or B. What do we know when they say that the event is mutual exclusive? We know that the probability of A and B has to be equal to what? To 0. So the first one there, for probability of A and B, it has to be equal to what? To 0. And the probability of A or B, what do we know when we have a mutual exclusive event? We know that the probability of A or B, it has to be equal to what? The probability of A plus the probability of B, minus 0, because this one is 0, the probability of A and B is 0 when the event are mutual exclusive. So from here on, probability of A were given, which is 0.6 plus 0.3, which in total is going to give us 0.9, So that's how we deal with that kind of stuff. So let's just take a look at the second one. It says that given that A and B are mutual exhaustive events, such that the probability of A, as you can see, probability of B, determine the probability of B, okay. They give us the probability of A. They want us to determine the probability of B. But they told us that these two events are mutually exhaustive. And when they are mutually exhaustive, what do we know? We know that the probability of A or B, it has to equal to what? It has to equal to 1. So that's what we know about the mutual exhaustive. So now they want the probability of B. How are we going to find it? We know that we have this kind of formula where it says that the probability of A or B is equal to probability of A, which we have the probability of A plus the probability of B, which we are looking for, minus the probability of A and B. Remember, exhaustive is different from exclusive. Exclusive is that's where the probability of A and B, it must be equal to 0. But here it does not matter. So here the probability of A or B, since it is mutually exhaustive, it means that it is equal to 1. And the probability of A, which is this one, is 0.1. Probability of B is what we are looking for, which is probability of B minus the probability of A. The probability of A is 0.4 actually, and the probability of A and B is 0.1. So this is the same as 1, which is equals to 0.3 plus the probability of B. And from here on, we can take this one to the other side, then the probability of B actually is going to be equals to 0.7. So that's where when it is mutually exhaustive, and here when it is mutually exclusive. So I'm going to end this video here. See you on my next video. Ciao.